I really want to touch about why ML even matters, especially to the customers. I want to talk about when we should be using machine learning, and more importantly, when we shouldn't be using machine learning, or at least when we should think twice about that. Also, one of the biggest realizations I've come to is that most people that do not build machine learning models do not actually have an understanding of how to map kind of this algorithm to a problem. Most people think of it as a big monolithic model that does everything, and that's the machine learning bit. So I'm going to show some examples of how reality actually looks like. I am also going to be focusing on one of the most important prerequisites to doing machine learning, which is data capture. And I'll be giving some examples of a Netflix TV show, which I'm really fond of, where I'll go through and explain really complex machine learning concepts. So hopefully just make it a bit more interesting and less dry. And I'll also be giving you a framework that you can leave with today that helps you map customer problems to ML solutions. And then the final two pieces is around unintended consequences in the evaluation metric that is used in a machine learning model, and the importance of having these cross-functional conversations and the need to have humans looped into decisions that machines are making. So, why should we care about machine learning? Well, like the previous speaker, Mike, he was talking about this expert that would be at a newsstand and sell you and know what to deliver to you. This is similar for machine learning. You'll take that human expert and scale it up so you can serve everyone. That's why it really matters. Personalization, really a word I don't like. I rather talk about content relevance, because personalization is really nonsensical in a way. I have it in my job title, unfortunately. But it doesn't really matter whether something is personalized for you. What really matters is it's relevant for you. So think about Fire Festival on Netflix. Many of you wouldn't have seen that as a personalized recommendation, but you saw that because it was trending on Netflix. And similarly for music. So we should instead be talking about relevance. And this is how machine learning makes that possible, but only if you have massive amounts of data. And then automation. Think about Google Photos or even Apple Photos and how they group together pictures and say, while you were at Istanbul. How do they do that? Well, this is the automation bit. They remove the need for you to manually have to tag those images. So it's a way of automating these tedious tasks. And if done right, they can improve over time. So when should we be using machine learning when we are building customer-facing problems? The first question I tend to ask when I'm helping the product teams identify the right solutions to be building is, does the customers you have prefer maybe one type of content over another type of content? And this is really to understand whether there is a one-size-fits-all solution. Because if there is such a thing as a one-size-fits-all solution, you shouldn't be looking at machine learning, which I'll cover in the next slide. And whenever we are talking about predicting a future event, that could be churn, that could be whether they convert or something else, we can create these probabilistic models that put a number to how likely that event is happening. And really interesting, this is often overlooked, learning hidden patterns in data. So if, actually a raise of hand, how many have read AI Superpowers by Kai-Fu Lee? Ooh, you're missing out on very interesting stuff. So he was the Google China founder, and he talks about a lot of interesting things that we people in the West wouldn't have access to. One of the things is a startup called Smart Finance, and instead of asking you a lot of questions to determine whether you should receive a loan, they just ask you to give them access to what's on your phone. You could discuss whether it's ethical or not, but in that same session, in that split second, they will let you know whether you have been approved or declined that loan. They did a presentation and they showed that the biggest factors to people repaying their loans was the battery level when they actually allowed that data transfer. The second most important factor was the speed of which they entered their date of birth. I mean, this is a challenge. Go find me a single product manager that comes up with such a hypothesis. I want to be tracking this type of data. It doesn't exist. This is where machines really take off. They can find these hidden patterns, these signals of truth amongst a lot of noise that we as humans can't. And uncertainty around what we believe is the right thing to be showing to the user, or even if the user doesn't know themselves what is the best solution to be showing them. This is touching more on multi-arm bandit and contextual bandit, which is really my biggest passion, maybe for another crap talk. And then finally, we need to be able to define what success and failure looks like as a numerical function, right? It has to be something that can be encoded into numbers, whether that's click-through rate, bounce rate, whatever it is. When shouldn't we use machine learning, or when should we think twice about that? Well, it's the opposite of personalization. Think about security. When you log into your Lloyd's Bank account, you want the same security that applies to you as to the person next door. So when consistency is important, we shouldn't be looking at machine learning or encryption for that matter. And also, when the cost of getting it wrong is too high, of course we shouldn't be using machine learning. So in multi-arm bandits, it tries to balance between exploration, so trying different things, versus exploiting what it knows to be the best thing. Well, imagine in stock trading where you have this AI agent that tries to explore what happens if it sells all of the stocks at the lowest price. Oh, that was bad. So you need to be able to afford that mistake as a company. And also, this really more applies to deep learning. If full transparency to why the model spat out the outcome that it did is important to you, then you really should think twice about deep learning, or maybe look into some surrogate models within the statistical models. Very important, listen. I attended a conference where an NHS director, so I was among the speakers, and he came up afterwards and asked this question. This NHS director was saying, we deployed chatbots and we don't understand why it went so wrong. Well, maybe people that are looking for human to speak to and they have a challenge, or they need some immediate help, they shouldn't be looped or stuck in that eternal loop of, did that solve your problem? No, then send you to some other question. So really pay attention to what your customers want and more importantly, do not want. And of course, if you don't have the data or it's very inaccessible, then you cannot be using machine learning. Right, so I promised this section on monolithic models. Most people think machine learning is on the left-hand side. You have one big expert model that does machine learning, this big black box. But in reality, what you have is this passing of the baton. So one model passes over the baton to another model, and to a third model, and a fourth model. Maybe you come visit Expedia's website. Then we score you of how likely you are browsing for business or for leisure. And then we string that together with what type of search results to return to you. So you have to think of machine learning solutions as a string of several models put together. Now, I watched this TV show on Netflix. How many have seen it before? Okay, 2. Right. This is really cool for a separate point, but they get to follow the drug smugglers and police. Now, what's really interesting is, maybe this is a work injury on my side, but I started paying attention to the police and what they were saying when they look out for drug smugglers. So police were saying they look out for any potential prior convictions, whether they are traveling during peak times, the degree of nervousness, if they had any custom work done, and whether you're using a smuggler vehicle or common smuggler vehicle. I thought to myself, this is very interesting because this is exactly data capture. A policeman looking for certain signals that then translates into whether drugs were found or not. So this is one way of encoding that data into a spreadsheet. So you will look at whether they have any prior convictions. So each row is a person that is stopped, the distance miles, whether they have a common vehicle. But in reality, there's no right way of encoding that information because we could just as well just capture which brand of the vehicle, And instead of a level of aggressiveness between 1 to 4 that the police officer scores, maybe you just want to say true or false. There is no right way of capturing data, but this is where the ingenuity of a data scientist and hopefully also product managers and analysts come together in these conversations to say, this is where we hypothesize there is a true signal. Say that we then spot which of these variables actually played the biggest role in identifying whether drugs were found in a vehicle. In this example, a mock-up example, we'll say whether they have convictions. But there's an interesting little segment here. Ooh, okay. Well, this police officer is saying, whenever we pick up this signal, the criminals, they pay attention to that and change their behavior so that they don't get caught. So that might mean that over time, they understand that every time some of their mobsters get caught, it's because they had prior convictions, or it's because they were using a common vehicle. So they will try these other things to kind of slip under the radar. This is really important because in machine learning, you have to think about the training patterns. So one way to do is we could build a machine learning model that can say, this is the most important, or these are the most important factors to someone smuggling drugs. But that would be a static model, and if we only update that once a year or something like that, maybe there would be so many false positives. We thought they weren't, but they actually were drug smugglers that would slip past the Mexican border. So there is this dynamic approach, which is that you keep on updating your model, maybe every day, or maybe even in real time. In this case, I would probably think that daily updating your machine learning model for those signals would be sufficient. But this is something that is often overlooked. So I manage the machine learning platform at hotels.com, and the machine learning deployment platform. And this is very interesting because most people don't think about the importance of deploying machine learning models. But in reality, this is the equivalent of learning a lot. As a student, you learn all of the things that get you prepared. And then once you get your first job, you have to apply that knowledge. That's what deployment means here. So how fast do we need to apply what we have learned from those signals before? Well, should we apply it on every 100th vehicle? Then that's what's called batch. Should we apply it on every single vehicle? Then that is near real time or real time. And in this case, that's exactly what you would be doing. I promised a framework that you could leave with to help you understand how to map customer problems to ML solutions. And this framework really focuses on the user context. So put yourself in this position. You have looked up and you can see that your flight has been canceled. You're there with a family. So as a family head, that's the context. Then we can use machine learning to anticipate their needs. In this instance, we can say, they may want accommodation, they may want food, and both of them needs to be family friendly. So how can we map those needs to ML solutions? Well, it's just about simplifying. It's about reducing the cognitive load. So instead of showing everything we have, we will use machine learning to only perhaps curate a little summary card that has the top properties nearby and the top restaurants that are family friendly. That's how you can use machine learning. So machine learning shouldn't be done for the sake of machine learning, but it should really be done for the sake of solving novel customer problems. I want to show you what some of the unintended consequences are of not defining the evaluation metric correctly. So this is a faulty reward. So an evaluation metric is the metric that you give the machine learning model that it needs to improve. Google DeepMind used a reinforcement learning agent to play this boat game. So look at the left-hand side. That's where the computer, the AI agent, is actually playing. They defined the metric as maximizing the score. And it found that by going in this loop and hitting all of those checkpoints and catching fire and hitting walls, it would actually accumulate a much higher score than had it played the track as it was intended. It's a very good lesson, right? So beyond this silly example, what this means is if you use something like click-through rate, for example, in optimizing, as an evaluation metric in machine learning. Okay, can we stop that one? If we use click-through rate on a website as the optimization metric for a machine learning model, maybe we could be accidentally optimizing for bot traffic, right? For web crawlers that are scraping our website and thereby hurting the users. These are real concerns that needs to be discussed as a cross-functional team, not just limited to one particular department. I'd like to give you this mock example. So imagine here you have user 1 and user 2, and they've gone to almost the same destinations. So user 1 has gone to all of these, but user 2 has gone to everything except the Philippines. How many of you would think that user 2 should be recommended going to the Philippines? A raise of hands. Don't be shy. Okay. How many think it shouldn't? Okay. All right. Some hesitation. This is interesting because it shows you the importance of having a human in the loop. Now, what I've done is I've curated the top 7 sex tourism destinations where women are being trafficked, right? And also children are being trafficked. But to a machine, it's nothing more than a mathematical function that it keeps optimizing and personalizing. So you could, if you're not careful, and if you don't have a human in the loop, you could be optimizing for sex tourism, right? Or even Facebook that has, find friends that are near me, or friends like me, or friends you may know, whatever they call it nowadays. Could you be, recommending other criminals? Well, this is the point. This is why AI cannot replace us in the near future. And this is why it's so important to have humans looped into those decisions before they're made. Thank you so much for your time, and I hope you enjoyed it, and you can reach out to me here.